what we want to be able to do is to determine the equation of a line given enough information. And this information can come in various different ways. So the ones that we look at are 2 points on the line. We can get from there to the equation of a line. A point on the line and the slope of the line. We can get from there to the equation. The slope-intercept equation form of a line is very important. We're going to focus on that quite a bit. And then we look at how to get the equation of a line from its graph. So like I've just said, we're going to focus somewhat on the slope-intercept equation for a line. But before I move on, let's just note that knowing the equation of a line then allows us to make predictions. And this is really why anybody anywhere studies maths, because it allows us to make predictions about all sorts of different things. I mentioned a few examples in the first mini lecture, distance traveled versus the amount of time that's elapsed for a body moving at constant speed, pressure, temperature relationships in a gas, the rate of photosynthesis versus light intensity. And on a larger scale, we can predict things like the, movements of prices in financial markets and the weather and climate change and an infectious disease spreads around the world. We can make predictions using mathematical equations. So the slope-intercept form of the equation of a line is something I'm going to focus on now for the next couple of minutes. All of those questions that I've just mentioned there, we can answer them by focusing on the slope-intercept form of the equation. So what is that form of the equation? In the first mini lecture, we saw the general form of the equation of a line. We wrote it as number times x plus number times y equals another number, a, b, and c. Now, if we rearrange that equation to isolate the variable y, well, we can write the equation then in the form y equals m times x plus c. And we can do this for any line which is not a vertical line. When we do that, what we find is that the number m that pops up there is always going to be the slope of the line. We can prove this. This is, not something I'm making up, and it doesn't come from some magical source. We could prove this if we were doing a mathematics degree rather than a science degree, we would stop at this point and prove that statement. This is something that's true. When we write the equation of the line in the form y equals mx plus c, m is the slope of the line, and the number c is the vertical intercept. Okay, so here's a diagram representing that. We have the equation written in the form y equals mx plus c, and what I've just identified here is that the slope calculated in the usual way, rise over run, for any 2 points on the line will be this number m in that form of the equation. And likewise, there's a geometrical interpretation of the number c, because what we find is that that will give us the vertical intercept. In other words, the point on the line where it crosses the vertical axis. So as I've flanked here, the coordinates of that point will be x equals 0 and y equals c. And indeed, we can see that in the equation. If we were to take x equals 0, we'd find that y equals c. In other words, x equals 0, y equals c satisfies the equation for the line and therefore represents a point on the line. So that's our slope-intercept form of the equation of a line. Y equals mx plus c, m is the slope, c is the value of y where the point crosses the vertical axis. So we call that the vertical intercept or the y-axis intercept. Okay, so then we're ready now to get to grips with a few examples. So the first one, as we see here, is asking us to find the equation of a line that passes through the points x equals 3, y equals minus 2, x equals 1, y equals 5. So there's a couple of different ways that we can do this, but we've just been talking about slope. So let's start by calculating the slope of this line. So we can use the fact that we have 2 points which will allow us to calculate the slope. And then what I'll do is I fall back on the idea that any other point on the line, that any pair of points on the line will give us the same answer for the slope m. So let's see how that goes. Okay, so the slope m is what? It's going to be the rise y2 minus y1 divided by x2, the run x2 minus x1. Okay, so what will that be? We have our values here. Let's take this to be the first point, x1, y1, and take this to be the second point, x2, y2. So y2 is 5, and I'm subtracting y1, which is minus 2. and that's all going to be divided by x2, which is 1, take away x1, which is 3. So when I tidy up there, 5 to take away minus 2 gives me 7. 1 take away 3 is minus 2. So I have overall minus 7 over 2. Okay, so we have our slope, m equals minus 7 over 2. Now to get the equation, I focus on the idea that any point on the line, let's say it has coordinates x, y, take any point on the line. If I calculate the slope, taking this to be, well, let's think of this as our x2, y2, we'll get the same answer for the slope. So I take any point x, xy on the line. If I calculate the slope, well, I know that the slope is minus 7 over 2. So this will give me an equation. This will give me the equation for the line. So what's the slope? Now, as I said, I'm going to think of this point here, xy. I'm going to think of that as my x2, y2 point. So I can write down y2, which is just y, take away y1. I have a y1 already. It was minus 2, right? Using that same point that we used earlier. Sorry, it's a very wonky looking 2. So I have y minus y2, sorry, y minus y1, y2 being y in this case, divided by x for x2, take away x1, and x1 was 3. Okay, so when I tidy up my minus signs there, what do I get? I get y plus 2 over x minus 3. Okay, so I'm using this idea that any 2 points on the line are going to give me the same slope. And I'm using the idea that x and y, like we saw when we talked about the equation of a line and its relationship with the graph, that xy being on the line means it will give me the same slope when I pair it up with any other point on the line. So I take xy to play the role of x2, y2 in my slope calculation. And now I can see what I have here. I have an equation that's going to give me a connection between y and x for all of the points on the line. So if I multiply both sides by x minus 3, I'll get minus 7 times x minus 3. Multiply both sides by the 2 on the left-hand side here, I get 2 times y plus 2. That will give me minus 7x plus 21 is equal to 2 times y plus 4. Okay, so I'm just about there. I suppose I'd usually keep the x's and y's on one side of the equation and keep just numbers on the other side of the equation. So if I add 7x to both sides and subtract 4 from both sides, I'll get the equation of the line in the form I'll have 7x plus 2 times y. I'm very good at 2's. Plus 2 times y equals, tidying up the numbers, what did I have? 21 take away 4, giving me 17. Tidy that up a little bit because that's pretty messy. What do I have? So I'm adding 7x to both sides. So that will give me 7x plus 2 times y equals 17, tidying up the numerical terms. Okay, so there's our equation of the line based on those 2 bits of information that this point lies on the line and this point lies on the line. Okay, our second question is asking us to identify which one or ones of these equations represent the line that has slope minus 2/3 and vertical axis intercept. So y-axis, what is just called q-axis in this case, the intercept is minus 3. Okay, so kind of hidden in the question is the idea that q is the y variable in this example. And as we see from the equations, the other variable is called t. So we're thinking of x equals t. So then the slope intercept form of the equation, y equals mx plus c, that really would read q is equal to m times t plus c. Now we're given the slope m, we're given the intercept c, so we can immediately write down the equation of the line in the form Q is minus 2 over 3 times T plus C, which is minus 3 minus 3. Now, the question is asking us to identify which ones of these are equivalent to this equation here. So let's tidy up this equation a little bit. I'll multiply everything through by 3, and I'll get 3 times Q is minus 2 times T minus 9. And if I put everything on the left-hand side, what will that look like? I'd have adding 2T to both sides. I'd have 2T plus 3 times Q, add 9 to both sides, equals 0. So let's think of that as our kind of starting point, our basic form for the equation of the line. So our job now is to go through the 4 examples, A, B, C, D, and see which ones of those are equivalent to this equation here. So 2Q plus 3T, that doesn't work because in this equation I have 2 times T plus 3 times Q rather than the other way around. So you're out. The second one, well, that's identical to the form that I've got here. Okay, so that works. Whoops, that's supposed to be a tick. Third one, 2T minus 3Q. Again, we see that that doesn't work because I have 2T plus 3Q. So that's out. And then the last one, 2T equals minus 3Q minus 9. Well, to get to that form, I would leave the 2T on its own and have everything else on the right-hand side. So if I take that equation and I subtract 3Q from both sides, and I subtract 9 from both sides, sure enough, I see that I get the form of item D there. So 2 of these equations describe the equation of the line that's mentioned there. Our last example, this one where I mentioned the importance of being able to take the graph of a line and determine the equation of that line. Okay, so again, I'm going to focus on the slope-intercept form here because I've been able to, by looking at this diagram carefully, I'll be able to identify the slope and the vertical intercept. So I've highlighted the point where it crosses the vertical axis. That's going to give us the vertical intercept. And I can see what that point is. It has coordinates x equals 0, and I can read off that the y value is 3. And that tells me that that's the value of C. Now what I need to do is figure out what's the slope. And the slope is the rise over the run. So let's say if there's a second point on the line here that will easily allow me to calculate the rise over the run. And I can see here that down here, this point here seems to have nice convenient coordinate values. That to me looks like the coordinates there have x equals 2 and y equals -1. Okay, so then I can calculate the slope, the rise over the run. That will be y2, take away y1, so that will be -1, take away 3, all over x2, which is 2, take away x1, which was 0. So what's that? That's -4 over 2. In other words, -2. So then I can simply write down the slope-intercept form of the line. Y is -2 times x, y equals mx plus c, which we read off from the diagram is 3. Okay, so there's our last one. I had to take the graph of an equation and pull information off the graph and pop that into our slope-intercept equation to get the equation of the line.